Good morning, everyone. My name is Janita Moorman from eWater. Welcome to our webcast this morning. Today we're going to talk about modeling catchments in eWater source. With me I also have Shannon, who's helping me out with the technical aspects of this webcast. Thank you for joining us. If you have any questions during the webinar, please interrupt me. We're very happy about that. Type your questions into the chat window on the GoToWebinar panel where it says questions, or you can also raise your hand by clicking the hand icon on the long left-hand part of the webinar, GoToWebinar panel. So what is source catchments? We'll start off by having a look at how we deal with catchments in source. Source is essentially a framework which provides an interface for the input, modeling and output of the flow and the water resources related information around your catchments. If we have a look at a catchment, any standard catchment, you have precipitation that comes into the catchment, various losses that happen along the way through evapotranspiration. We might get losses to groundwater. You'll also find that you might have water that is held back in a reservoir in some manner. Water is provided to various irrigation water users. And then, of course, you have the impact of the general landscape on the movement of water through the system, through the land cover, soils, slopes, and other such factors. So source deals with all of this through the creation of models and various scenarios. Two types of scenarios that you can build in source. You have a schematic scenario. On the left-hand side of the screen, you'll see an example of a schematic scenario where the geographic location of the points is less important, but the connectivity of how points relate to each other is very important. On the right-hand side of the screen, you'll see an example of a geographic scenario. Now, a geographic scenario, that is what we will be focusing on in this course, is how we build our rainfall runoff modeling into a geographic scenario, where we're actually interested in the connectivity that happens between catchments and how water moves through our catchments. A standard source model is built up of nodes, and these nodes are joined together with links. In the middle of the screen, you'll see there is a node palette, which gives an example of some of the nodes that can be used in source. Standard kind of nodes that one is interested in is perhaps a gauge node, a storage, a water user. In the catchment scenario, the most common node is the confluence node, which joins together flow from different catchments. So let's have a look at what the standard procedure is for building a catchments model. Your basic building blocks consist of catchments, functional units, which represent landscape features such as slopes, any thing where you would expect a similar hydrological response. On top of this, one builds a rainfall runoff model. Optionally, you can add constituents through a constituent generation model or a constituent filter model. And then, of course, driving this whole process are the various climate variables. So we look at it in a slightly bit more detail. One will start off to bringing the catchments into source, for which you could need a raster, which shows your original catchments, or source will create the catchments for you from a digital elevation model. To this, one adds any features of interest, such as gauges or storages. You have outlets. These are the points at which you're interested in monitoring the outlets from the catchments. And then, of course, one has the various functional units that impact on the landscape in your catchment. In terms of time series data, the climate inputs, rainfall and evapotranspiration are input as climate series, time series. Observed flow and observed constituents will be used to measure the success of your model and to calibrate later. And then once one has built a model You can record various aspects of the model and view the model outputs through what we call in Source recorders. So as we step through, you start off by creating a new project and a geographic scenario. You will then define the catchments for your model. You'll be interested in knowing how many catchments you're interested in and how big you want those catchments to be, where the outlets will be, any other features of interest inside the catchment, such as storages. Functional units. Functional units are used to assign areas inside Source. Choosing a rainfall runoff model, parameterizing this rainfall runoff model. We will then optionally add constituents and parameterize a constituent generation model. Once one has set all this up, you set the elements that you're interested in recording, run the model, examine these outputs, and then calibrate this model. So what is model calibration? Model calibration is the process of optimizing or systematically adjusting model parameter values to get a set of parameters which provides the best estimate of the observed streamflow. And when you're calibrating in Source, one has the option to choose the feature you're going to calibrate on, which could either be a gauge at which you have observed flow, for instance, or observed constituents, or one can also calibrate on a river reach. There are a number of objective functions available in Source against which one can calibrate. Source provides an option to select a warm-up period, to select the parameters against which you will calibrate, and then select an optimization function which will actually perform the calibration. There are, in the version of Source that I will be training on in June, there are 4 standard objective functions that have been included. This, however, is a list that is increasingly growing over time. So in front of you, you'll see a typical empty Source screen when you open up Source for the first time. There's an option to choose the type of model that you're going to, the scenario that you're going to run. Source is creating a new project and it's going to create a catchment scenario. I'm going to create my model using a digital elevation model. I'm going to create my catchment, using a digital elevation model. Source automatically generates streams and can, if asked to, automatically generate the catchment outlet. You can select this catchment outlet as well by selecting a point on the Source window. The number of catchments and the size of these catchments can be controlled. Once you're satisfied with the catchments that you've chosen, we'll add the functional units. I'm adding functional units from a shapefile. And in this example, the functional units I've added, I have only used land use. Commonly, one would have a slightly more complex functional unit. Source will now automatically create the areas of each functional unit per catchment, which it has done. Once one has created your initial Source screen, the next step is to decide on the models that are going to be used. We will also add constituents. So I will add a very simple constituent. I will choose a rainfall runoff model. There are a number of rainfall runoff models available through Source. For this example, I'll choose the GR4J model. And we can copy and paste to all points in Source. Once we've chosen the model, the next step is to select the rainfall inputs and various climate inputs. Evapotranspiration is generally measured in millimeters per day. Rainfall. For this model, rainfall will be measured in millimeters. There we have our rainfall. I'm going to finish off selecting my rainfall runoff model. And pasting it there we are. I think there are many ways to do this. You might have noticed in the drop-down menu that there are a number of rainfall runoff models that are available in Source. I have chosen the GR4J model because that one only has 4 parameters. So for demonstration purposes, it's generally a fairly good model to use. Similarly, add the evapotranspiration. At this point, I see there is a question that asks, are these data sets all taken from BOM? So have we got these data sets from the Bureau? Well, commonly, if you're in Australia, you should be able to get rainfall and evapotranspiration data sets from the Bureau, yes. You can also get these data sets from the various state jurisdictions, I believe, have websites from which you can offload relevant data sets. Does that answer your question? Another question. What is the benefit of selecting the GR4J model? Well, let us have a look. I selected the GR4J model. As soon as I selected that model, the parameters came active. The GR4J model has proved itself to be quite a good model despite the small number of parameters. And I can also tell you that often we have found here at eWater that it performs just as well as some of the parameters such as Sacramento, which have a lot more parameters. Models such as Sacramento, which have a lot more parameters that have to be calibrated on. So GR4J is often a good model to start off with when you're doing your rainfall runoff modeling in a catchment. Thank you for those questions. There is a default. There are default parameters that are chosen at the start of any model run, and these get filled in automatically once you've chosen your rainfall runoff model. You also don't have to have the same rainfall runoff model for all parts of the catchment. If you know that there is a particular functional unit that responds differently, and you might want to have a different rainfall runoff model on that piece of the functional unit in that catchment. So I might perhaps want to model forestry in a different way to how I model general agriculture. And so therefore I might choose a different rainfall runoff model. Source has a number of predefined rainfall runoff models. It is also possible to build in your own rainfall runoff model by writing a plugin, which will then add that model to this list. I see we have another question. And the question is, what is the best format of climate data to be taken up by source? Well, that is a good question. And often the format of the data depends on what you have available. So source provides for time series data inputs, where you will get data that has been measured at a local rain gauge or at a local evapotranspiration site. Source can also, we won't be discussing it in this webinar, but Source also makes provision for data to be loaded in as rasters. So if you have data in Australia, for instance, you might have data that is from, you can get rasters, grids of rainfall and evapotranspiration data from the BOM website. One can load those grids into Source as well. You can also load, there are public versions of these data sets available, such as TRMM, which one can also load into Source. Again, that is a raster data set. Another question. Please, can you explain a bit about rainfall runoff models available in Source and about widely used models in Australia? A number of these models that we have in this list, I've opened that list, have been developed. AWBM is the Australian Water Balance Model. IH-ACRES, again, is a model that has been developed for Australian purposes. Sacramento is an international model but is widely used in Australia. SimHide also typically is a locally developed model. And then there is another question I see. Should we incorporate rainfall as millimeters or millimeters per day? Source currently incorporates rainfall as millimeters, i.e. as a depth. Now, the reason why we have implemented it in that way is, well, there are a couple of reasons. One of those is because some of the models request it in that format. Also, we don't always run Source at a daily level. So introducing rainfall as a depth, converting it to a depth before you bring the rainfall or evapotranspiration into Source means that you can implement it at time scales that are less than a day. Right, thank you for those questions. Now that I've set up my rainfall runoff model, next thing to do is to set up the constituent model. You remember we added a constituent of sediment. Have a look at some of the constituent models that are available in Source. Source looks at constituents. There are two types of models. You can have a look at modeling the origin of the constituent and as it moves across the landscape with a generation model, or a filter model, which filters some of the constituent before it reaches the stream. I'm going to check my constituent again that has been applied. add sediment, and now I can choose a model. For this example, I will use the event mean concentration dry weather concentration model. What that does is it divides the constituent between high flow events and low flow or base flow. Apply that throughout my model. I am assuming some numbers of 60 milligrams per liter for the flow event and 10 milligrams under dry weather circumstances. Okay. Thank you. We have another question. SimHide has a version for routing. How about the other models? Do they have a routing factor? Some of the models introduce lag, have a factor for lag, and also routing can be applied inside source on a link. So you can edit a link in source and then apply routing at that link. Okay. Change my routing back to straight through routing for this example. So now we have set up all the basic parts of the model that we're going to be using today. And the next thing to do is to record the model run. So I've decided that I would like to know what my flow and my constituent loads are at the exit to this catchment at this point. So you will notice as I select on a link, on a node, that node comes active in the left-hand window, and in the bottom part of the window, there are a number of recorder variables. So at this particular node, I'm interested in knowing about downstream flow, and I would like to know about my constituent outputs. Configure the model by setting up the dates that you want to use for your run, and then run the model. There is a progress bar that shows how the model run is progressing. And the outputs are available as a graph or as a table, and you can also look at various statistics surrounding these outputs. So I have looked at my flow. I can look at and there's the load. Of sediment that was available at that point. Similarly, one can record downstream flow and constituent output at an upstream point as well. Run the model again. A new scenario run appears, and flow at the most downstream site can then be compared to upstream flow. Right. Are there any more questions at this point? Yes, I see we have one. Please recommend the best way to introduce routing, that is using SimHide with routing, or define routing at the links, or any other way. Ramanan, thank you very much for that question. I think it would depend very much on your use, but I'm going to ask one of the other hydrologists, who is more of a specialist in SimHide, to get back to you on that one. Thank you. To my source model, yeah, and I can, there is CERM, which is an urban modeling package. Yeah, and then you would specify your functional units according to those which are relevant in your urban catchment. Any more questions? Okay, I see there are a few more questions coming through. Right, the question is there a general size that this has been developed for? No, this source has been used on very, very large catchments. And as we mentioned with CERM, you can also use it on smaller urban catchments. So no, there's not a specific size that it has been developed for. Another question, could it be used to model water balance in catchment without considering rainfall as the main water source? If you're wanting to do that and you have other water sources, I would recommend that you maybe look at creating a schematic scenario, because rainfall runoff modeling does need rainfall as an input. But if you have your flow existing, you can create a schematic scenario and then load the existing flows. Now, the next question, how do you calibrate models for the different functional units to optimize parameters? Adam, I haven't included any detail on that in this webinar, but Source provides an option for flow calibration analysis. And within those options, gives you the ability to choose the parameters as well as choose specific functional units or catchments that those parameters are going to be calibrated on. And we call them in Source, we would then call that subset of parameters a meta-parameter set. Next question, I want to introduce a reservoir storage with the catchment. Within the catchment, how is the node added? What you would add that node at the original point where you create your catchments. You would then add your storage as a node. And any one of these nodes, the confluence nodes, can then be changed to represent a storage. And once that storage is created, you can configure the dimensions and the outlets of your storage. This webinar, I have a question here saying, is this webinar available for access while building a model? The webinar will be made available through the eWater website, and it can also be emailed to and we will send you an email when it is available. Next question, is it possible to create or edit catchments through the schematic scenario? Currently, no, it's not possible. The schematic scenario does not access the catchments, but you can. There are two. I'm clicking between a schematic and a geographic view of my catchments model. So while I can't edit the catchments through the schematic scenario, I can Right, more questions. This isn't the last chance that you have to ask questions. If you do have any more questions around this webinar, you can post them on the eWater community site and we'll get back to you. Anything? Right. I think it's good to wrap up. So thank you very much for joining us at the Modeling Catchments in Source webinar this morning. And don't forget, if you're interested in coming along to a course in Brisbane, it would be really great to see you there. Thanks, everybody.